Once again, good evening, everyone. Tonight we have Minty. He's a computer vision engineer and turned data scientist, right? Is that right to say so, Minty?
Yeah, that's right to say so.
Okay.
So my name is Tan Min Tee, and I'm a computer vision engineer. How my journey started is I was an E&E engineer in bachelor's degree, and I studied master's in embedded intelligence systems. And from there, I started venturing into AI. And for my final project, I did something called convolutional neural network, and that piqued my interest. And I was like, wow, this is very interesting. And then from there, I did projects and stuff. So when I come back to Malaysia, and then I got a job for a computer vision engineer in a startup, a robotic startup company. So that's how I got here.
Maybe can you introduce quickly what is computer vision or what is CV?
Right. So computer vision. Computer vision stands for CV for short. So it's a field of study that technically helps the computer to see. So we try to do like algorithms or coding to help the computer to identify, such as image recognition or track an object, or even multi-label classification. And so the computer does is they extract the features in an image, because what the computer sees in the image is all the 10s, or if let's say it's in a RGB form, will be 0 to 255. The RGB stands for red, green, blue. Then the computer analyze it, and then it will understand and learn that, okay, this information is what I'm supposed to recognize. So this step actually requires a lot of data. The data here will be images. So after that, we'll do some image processing. Image processing such as cropping the image, rotating the images, increasing the brightness or the contrast. So then it will sort of create new images out from the existing images. So modifying it, and then from there, it will make sure that these informations must be known for these informations. So this process is called image augmentation. So, and computer vision is a subset of artificial intelligence. So basically, it is artificial intelligence. AI is let's say like a big mushroom. So under there will be machine learning, deep learning, computer vision, even robotics, IoT, all those things will be under that big mushroom. Yeah. So that's the brief introduction to computer vision.
Okay, so one quick questions I have for you is that you mentioned that you learn CNN, right? Is that for your FYP or part of your curriculum?
Actually, it's for my FYP.
For FYP?
Yeah. For the curriculum, they only teach us the basics such as fuzzies and also neural networks. So the artificial neural networks. But from there, it piqued my interest, and then I chose this as my FYP. So when I did CNN, I did for the MNIST data set, which is numbers and handwritten by I think for around 27,000 images, I think, if I'm not mistaken. Yeah.
So your FYP is more on the digit recognition, handwritten digit recognition, right?
Yep. So basically, what my FYP is, I compare all the, I wouldn't say not all, selected machine learning algorithms and deep learning algorithms, which in this case is CNN.
Okay, for those of you who are not very familiar with this field, right? CNN is a type of neural network, which is more commonly known as deep learning nowadays. How much performance improvement it gives you when you switch from, let's say, a traditional neural network to a CNN?
For this MNIST data set, it actually increased around 10 to 15% of improvement.
So for somebody like most of us here, right, they have never ventured into computer vision. So
Mhm.
what would you think, or what would you say that is the biggest myth for somebody who have never looked into a computer vision work before? Like they, if you have never touched on this, you might be thinking, oh, this is very difficult. But I'm sure that after you have learned it, there are some myths that you have debunked and say, hey, this doesn't look as hard as it seems. So is there any instance that or any moment that sparked you like that?
Well, definitely. Well, the one of the biggest myth is that I would say when people see AI, they think it's magic. They feel that the AI should recognize things very easily, but it is actually done after a lot of training, a lot of images, a lot of data. Um, from there, you have to annotate the data, which takes a very, very long time. And also after that, you have to find the suitable algorithms to train it. And then even let's say the training accuracy says it's 99%, but when you test it, it might not actually be 99%. Yeah.
So let's talk about AI a little bit, right? I always
Yep.
say that AI is actually nothing but just specific automated or highly intelligent applications of a particular field in a particular
Mhm.
field to tackle particular problems, right? So maybe you
Yep.
can share a little bit on the applications of CV, application of computer vision.
So applications in computer visions are such as you can see on the screen, will be the more popular ones will be license plate recognition and also crop monitorings in the agriculture field, or even traffic flow analysis. And after these are some of the applications. So now because of COVID-19, so mass detections are pretty common right now, as you can see in malls such as the Sunway Pyramid or even gardens. They have mass detection to tell you guys that, oh, guys gotta wear masks. So these are applications of computer vision, and also road condition monitoring. So for, let's say, the roads are, there's like potholes or even like a puddle of water. So these applications can help to fix the road faster, and know how much damage it has caused to the road. And then there's also another thing for agriculture field, which is animal monitoring. So you monitor the animals, or like you can even count the animals if you want to. And another thing is text scanning, such as, like, I'm pretty sure somebody in this session right now has used before a cam scanner, which is the app to scan the documents that you needed, and then it can actually scan your text as well. So, and then the last one will be super resolution. This is a bit more advanced. This is actually in another deep learning algorithm, which is called GAN, Generative Adversary Network. So that one is a little bit more advanced. Won't get too much into detail. So these are some applications that can be seen.
For the list of applications that you have mentioned here, right? Which one is there any one of them that you have done it before?
Actually, I did before is license plate recognition. Another one is the road condition monitoring and also traffic flow analysis. So these are the ones that I did before.
Okay, so you did basically related to transport, right? So I got
Yes.
a question for you. Do you think
Mhm.
it's possible to use this application to detect potholes on Malaysian road?
Actually, very hard.
Why is that so? Because
Because
okay, every time when I judge a hackathon, right,
uh,
there will be people pitching something like pothole detector. So, but yeah, I would like to hear from you. Why is it very hard?
well, first of all, because even if, let's say, you find the data set and whatsoever, you got to make sure the image augmentation is very good, because in the real world you have like sun, you have rain, you have a lot of noises to interrupt the detection. So sometimes when there's there's like that one time, like the condition is something that the model has not seen before, and then it will not detect it. So that's one of the challenges, I would say. And also because it is very the thing is similar to roads. So that's one of the another challenge as well. So it is very hard to detect it actually. So yeah, that's what I did. But for this one, in the end, for this project I did halfway, and as in like I did the detection out, but then the client just decided to call off the project. So that's a shame as well. I didn't get to finish up that project. So that specific project, yeah, actually.
But I don't know, I got a feeling that potholes is not something with regular shapes as well. So the difficulty increases as well, right? Lighting condition is the main obstacle. Actually, lighting is one of the biggest challenge in any sort of computer vision project, because
Yes.
yeah, for example, if you want to detect the pothole or to count the cars at night, is going to be extremely difficult, and facial recognition when the lighting condition is bad. So what I've done
Yes.
is I did crop monitoring and animal monitoring when I was in Australia. So when I worked at Microsoft before, so for the crop monitoring, what happened is that, so Australia is very big, so they have a lot of land, and then they use that to plant things like for example some of the tropical stuff that you can see in Malaysia is like sugarcane. Sugarcane is one of the most popular ones. And then what happened is that if you were to monitor the quality of the soil, for example, and because Australia doesn't rain that much compared to Malaysia, you have to always drive to the field and gather the sample, soil sample, and also gather the gas to check, okay, or to analyze which gas or greenhouse gases actually contributes to the crops. So they are like methane, for example, and nitrogen. These are the common ones. So you cannot do it manually because you have to open the shaft for like collect the gas samples and then close it. So these have to repeat every 15 minutes. So it's one of the easier way to use sensor networks, like what you call IoT today, to do that. And then for crop monitoring, the monitoring itself is what we did was very simple. So basically we put a ruler beside the sugarcane as a benchmark, and then we take pictures like every 3 to 5 days or every week, and we send the picture back and use that to check how many pixels it has grown, and then use that to match with the ruler to measure the growth. That's one of the things that we do. And or any animal monitoring, we didn't use a computer vision method. We use the GPS method. What happened is that koalas, right? Koalas is we all know koalas is cute, right? But koalas are very fierce, and koalas are very lazy. They sleep about 18 to 20 hours per day. So it's very hard for a zoologist just to take binoculars to look at the koalas sleeping most of the time. So we use a camera and also GPS tracker to put on their neck, so to keep an eye on them, and we can detect motions and analyze what they are doing as soon as they wake up. Yeah, so computer vision is a very interesting field.
So basically, this is a object detection project. So this is using the YOLO V4 algorithm, which is, if let's say anybody wants to go into computer vision, is definitely a very common deep learning algorithm. It is open source. You can actually just install, plug and play.
Can we describe a little bit of your intention, like what you did, or why do you do this, and then what? I think I'm more interested in what sort of problems you solve.
Oh, okay. So actually, this why we did this is because previously my company was actually a drone company. So you see this footage is actually aerial footage. So I'm trying to use aerial footage to imitate a drone footage. So basically, this one I didn't get to modify it a lot because the algorithm is actually very strong itself. So I used it. I'll show in one of the sample projects. I used the YOLO V3 instead of V4, and then we use this to count cars and count vehicles in the traffic flow analysis, and also we tried to do an algorithm to do a speed sort of like speed trap. So calculate the speed based on how much this car gone to this, sorry, how much a car gone from A to B, and it's like calculating how much pixels it is. That one we did it as well, but it's a little bit, I would say, a little bit inaccurate. And yeah, so actually this is more like a plug and play for this. It's not really a project, but it's like more like installing and then plug and play and then show. This is actually a very, because this algorithm itself is actually very powerful already. Comparing to the V3, it might not even actually detect all the cars or even detect the persons on the motorbike. So V3 is V4 is a very powerful algorithm. This project is a clothes recommendation system. So basically, you put an input image, and then the output images will be something like a very similar to the input image. So for this part, I put in 10 output images. So as you can see, when I change every time, then it shows the similar kind of close to the input image. So for this one, I didn't use YOLO. I used transfer learning. Actually use the FastAI framework. Did transfer learning using the ResNet 50 pre-trained model. So this basically I did was combining 4 neural networks, 4 CNNs into one, and then using another machine learning algorithm which is called Annoy. So Annoy is basically nearest neighbors. So that one is more like they show you how close it is similar. So they see a score, and then the more similar the score is, then the model will choose the 10 most similar close to the input image.
So this data set is not on Kaggle or anything that they provided.
This data set, I mix and match a little bit. So I got some from them, and then I got some from the net as well. This data set is called called Deep Fashion data set.
Oh, next one is interesting. I think this your next project. Everybody needs this project. Everybody needs this.
I did it out of fun because it is actually when the start of COVID-19, when everybody started to work from home, and then I had some time. So, and then my company was like quite stalemate. Didn't have any projects coming in because it's a startup. So I just decided to do this project for fun. So this uses I use OpenCV, which is an open source package as well in Python, and I use YOLO V3 instead because OpenCV that time has not integrated YOLO V4 yet. So that's why I use YOLO V3. But it is, as you can see, is still recognizing people is very easy for YOLO because if let's say you look deeper into it, YOLO has a lot of images for people, so it's actually very easy to recognize people. And then the distance uses the OpenCV as well, like basically seeing the distance between the people. As you can see, when it is green, it is safe, and then when it is red, it is not safe, and orange means that.
Well, that one is interesting. So, so the risk is basically detected based on how close they are, right?
Yes.
And how do you measure the distance between two people? Is based on the pixels, right?
Yeah, based on pixels actually, yes. I didn't use any data set for this because OpenCV, they already integrated YOLO V3 into, using OpenCV, and then I just basically write a line saying that use YOLO V3 algorithm, and then it will show like this. So using OpenCV.
You have shown us 2 types of projects so far. Basically, one of them is video, one is picture, right? But they both fall under computer vision category, but they are the same but different. Video, a movie, and still images, they're entirely different. So maybe can you quickly tell us what are the differences and like challenges, or what are the things that you enjoy the most while working on images and also working on videos?
Actually, for the data set itself, for the training data set itself, I only use images. I only did with images before. I think I saw people saying that you can train using videos, but I have never tried that before. So I only did images. So I can only give images. So I would say the biggest challenge is very time consuming if you do not have a data set that is annotated. So I did another project when I had to recognize the types of ships. So basically, we have to classify 4 ships. So 1 is cruise, 2 is oil tanker, 3 is cargo ships, and 4 is a fishing vessel. So that was actually when I first joined the company. I had to web scrape the images. From there, I would say, the biggest challenge is actually annotation. Yeah, annotation for data collection and data cleaning, actually, because it's very time consuming, and it is something that I personally do not enjoy to do.
Is it because, okay, put it this way, right? Some of our DSI 360 students are here, so we all know that getting annotated, labeled data, or you call it ground truth, is the hardest thing in any data science or machine learning work.
Yes.
Yeah.
Yes.
But for your case, in your case, is it just time consuming, or is it because like it's subjectivity? So in some of the competitions that I went before is because of subjectivity.
Yeah, actually it is subjectivity. It's just that I just myself, I just do not enjoy doing like things that repetitive. So I just really love to look into code and then basically debug anything that I can do, and then try and error to see which pre-trained model that I would love to use. So that's what I enjoy. I enjoy more the annotation, I would say.
That's the last project that you have prepared for us, right?
Yes. Yeah. So this project is This is one of my colleagues. So this is basically another open source as well. So this uses another Python package which is called OpenPost. So as you can see, there's like a yellow line, green line, and red line. I apologize for the resolution because that's the best the DJI Tello can give. And it uses DJI Tello, and then it tracks the person, and it uses the library called OpenPost. So as you can see, when it uses different poses, and then the DJI Tello will react to how the post is. So OpenPost is actually a very, very interesting project, the open source project. I really recommend if anybody wants to go into computer vision, because it actually uses in a lot of applications such as like sports, basic, like for example, seeing the free throw of a basketball player, and it calculates how many percentage the ball will go in, or even golf swings. So these are some of the applications this OpenPost did. So this uses OpenPost and OpenCV as well.
Next up, I would like to invite Minty to share something about the workflow of computer vision.
So as you can see on the screen, basically, so the most important thing in a CNN project, a deep learning project, or a computer vision project, is the data. You really need a lot of data, and after that you have to the data in here means images. After that, you have to separate it into 3 different evaluations. So training, testing, and also validation. So training data basically means the images for the model to learn what it needs to recognize. Validation is when it is training, and then it sort of like validate, okay, is this correct, or is this wrong? And testing will be, as the name said, testing the data set. Testing the data set will be showing the performance or accuracy of the model after it is trained. After all that, you put into an algorithm. In my case, I utilize a lot of CNN, so it will be the convolutional neural network algorithm, the deep learning algorithm. And then after that, it will go to the evaluation and also to the model. So the model will be some sort of like so as you can see here, production data. So the data you put into the model, and then it will predict it will make predictions such as you've seen on the clothes recommendation system. So basically, the input image of the input image, and then put it in, and then it will predict the output images that are similar to the input image. So that's a brief explanation on the computer vision workflow.
Which part do you think, and when we do data science, we do have something like Awesome Framework, and this is part of the CV workflow, right? So in Awesome Framework, I think I always say that cleaning data is the hardest part. And in your case, do you still think cleaning data is the hardest, or getting data is the hardest?
Yeah, I would say getting data is actually harder, because a lot of it depends on what algorithm you use. Such as if let's say you use YOLO, the algorithm basically helps you augment the data when it's training. So you can actually set like, okay, you want to rotate how much, or like you want to change something for like how much. The algorithm itself helps you do that. But so in my case, I actually feel that collecting data is actually much harder, I would say, because images are very hard to come by. Because if let's say you want to train the model from scratch, you actually need a lot of images. Sometimes even let's say 10,000 images is not even enough. So actually a piece of advice for people that want to go into computer vision: when you train your data, use transfer learning, because training it from scratch is too much of a headache. Transfer learning is actually, I personally feel, is the way to go.
But the problem with transfer learning is, let's say we have. I'm asking this as a normal people will ask you, right? The typical deep learning subject that we have seen everywhere, I think you know where I'm going, is the cat and dog data set.
Yeah.
From the MNIST data set that you're doing. And but of course, number one is many people don't see the application use case of recognizing, differentiating an image between the cats and dogs. And if you throw an image of a zebra, I don't know which way you will go. Like, sometimes you'll tell me it's cat, sometimes you'll tell me it's a dog, right? But you'll never tell me that it's neither these or it's a zebra. So if you use transfer learning, will that like limit yourself to look at new type of objects?
Actually doesn't affect, actually, because basically transfer learning, what we call is actually just you freeze a certain amount of layers on that CNN. So you basically use if you imagine it, it's like the top part of the CNN, and then after that the bottom part will be changed into whatever that you want to recognize, I would say.
So if I were to explain it this way, right, can I say that you can build a CNN that recognize the structure first, that recognize the outline, then it recognize the texture, for example. Am I right to say that?
Yes.
Yeah. Okay.
Yeah.
So let's say I want to recognize cats and dogs and zebra. I can freeze the shapes layer because they are pretty much similar. Let's say they have 4 legs, for example, right? And then only I teach the machine to recognize based on their texture. And if I want to recognize other type of animals, I don't know, maybe cow or sheep, then I don't have to retrain the first layer. I can transfer that part of learning, and then I can add on every time, like when I need to train for it to recognize the new animals, I just need to add in new skin or new texture.
Yes, that's correct.
Yeah. So for those of you who are listening, this is basically what convolutional neural network or CNN does. Right? They have many different layers that you can learn, and what Minty was saying just now, a part of the learning that you learn from a data set or for a particular model can be transferred to another model and used as a basis.
Hey, and welcome to this channel. My name is Ruben, Head of Marketing at Lead. On this channel, you'll find content, tips, guides, and also tutorials on data science, web development, and digital marketing. Make sure to subscribe, and we'll see you in the videos, content, and workshops, courses to come. Thanks again.